So I did a 2D drawing of the spokes that would support the rise. So if you look at the bottom of if when you look at the bottom of the rice dryer, it would have these supporting structure. So the dimension of the rice dryer is 53 inches, and the spoke has a length of 25 inches. The center pipe would rise vertically, and it would dry the center of the rice mass. So from center to here is 12 inch, center to there is 24, and then 48. So I would then spread a screen on top of this. It would be supported by some feet, so that it would support this and raise it up 8 inches above the cement floor. So here there would be a supporting metal pipe probably. So this is the plan view, and all around it would be nichrome wires, which I would make. I'm not sure yet what wattage I'm going to use. I think it has to do. I think it would have to be some sort of an experiment. For example, from center to here, that's 24 inch. So heating element here, from there 48 heating element over here, and within this containment system there would be fan to mix the cold and air with the heater, so that it would be evenly heated to 43 degrees. Of course, it would have to be calculated in some way that it would achieve 43 degrees C to heat up the air. It probably would, because as the air permeates to the rice, it wouldn't be like the flow rate of the air wouldn't be fairly high, but there would be some, I don't know how many psi of air would be here, maybe 5 psi. So the air within this, underneath this, would be pressurized, heated to 42 degrees, and then the air from here permeates up through the rice hull or rice, and drawing away moisture, drying the rice, individual panicles. My objective is to have this whole thing dried in less than 8 hours. But we'll see how that goes. I mean, I'm just looking at this and doing some preliminary guesstimate on how long I should make, or how long it would take the for the rice to dry. Let me just save this. It's thunder and lightning again, and if I don't save it and the lightning would strike the transformer, then we just and I didn't save this. Let's see, AutoCAD. Yeah. Gee. Okay, it's safe. Yeah, thundering and lightning. hopefully I won't blow the fuse. So I added the flat bar to the drawing. So this flat bar sitting edgewise is 1 inch width and 25-inch long, quarter of an inch thick, and it would be supported here. I haven't installed the support. I had to figure that out. So the flat bar can be seen. The flat bar can be seen edgewise. So the this line would be the cement, and here the proof of concept of the heater would be wrapped around, not wrapped around, but in place in a circular manner. I would have to recalculate the wattage. So if I look at 1 kilowatt or 2 kilowatt heating, then I have to look at for example 2 kilowatt, and 1 hour is 2 kilowatt hour, and multiply that by the peso. So 2 kilowatt hour, right now the per kilowatt is 15. So 20 peso, 15 times 2, 30. 30 peso per hour times 8. So that's the potential cost to electrify the rice dryer. Now it all depends whether I want to do it slowly or do it quick. Doing it quick would require a lot of kilowatts. Doing it slowly would require less, but it would use up time. If it does use up time, I suppose it's irrelevant. Philippines are time rich, so there would have to be a trade-off: cost versus time. Cheaper for doing it quick, or is it cheaper to do it for a long, let's say 16 hours, for example? So it all depends. So now that I have this proof of concept in my head, this thing right here is actually quite tall, but from here to the top of the pipe is 43 inches. So this whole area here would be rice. Actually I could calculate the volume. Well, hold on, let me calculate the volume. Okay, let's see. R is 26.5. Height is 43. So the volume is 94,000 cubic inch. Actually, what's that in feet? Anyway, let's see. Well, I can't be bothered to convert cubic meter or cubic yard or cubic feet or whatever cubic. But anyway, in the case of this is 94,000 cubic feet. Oh, I'm sorry. Anyway, this thing has 94,000 or 95,000 cubic inches. I'll factor that conversion to feet, yard, and meter later, cubic meter. So this whole thing, not factoring in the space taken by the pipe, It's probably 93 or 90 cubic inches. Um, since I'm using imperial to as my unit of measurement here, I could have used metric. The CAD did ask what kind of unit of measurement, and it only gave me. I chose imperial since I'm so used to imperial in the past, so did that. So I'm just gonna do the mock-up of the rice dryer using bamboo slats. Not that girl. So I'm mocking up the dryer. Basically, these would be the base, and underneath here, for example, would be a metal screen. The again, mocking it up, it would be similar to this. That's the reason why the spoke needs to support the metal mesh, because they're flimsy, and I don't know how many kilos or tons of rice I plan on doing. So the more it needs to support, say, a ton of rice, then the spoke needs to be closer together. If the rice is not so heavy, then the spoke could be wider, and this would support it. The mesh gap, it's too big, so rice would just fall through. So it would be a finer mesh. Later on, as I could fund this, it would be those steel plates, maybe gauge 48, that I'll be using with lots of holes. So I'm going to use a bamboo for the mock-up of the spokes. I don't the metal bar, I'm using it for some other purpose, and I only have this piece left. By the way, if you're these, when you buy these from say Roxas, the Philippines, they're so flimsy, you just tug it, it will just come off. So send yourself these. I had my sister Becky send me these, and they're quite thick. This is thin, you know. It's just I just use it initial support, and then use this thicker tie. So send yourself. It's actually very helpful to have around. Send yourself the big one, the long ones, the foot ones, or even longer, because these made from China is flimsy. Quality is quality. It doesn't exist. So the one you get from North America, you know, when you're buying this, it will last and it won't degrade as much. This just flimsy. As you can see, it just came loose. So I'm just gonna cut this up, mock it up. It's you don't want to buy expensive materials, because you don't know yet how this would look like. I mean, the drawing tells me what it would look like, but reality sometimes will force you to say, need some adjustment. Oh yeah, what's the reason for this? Well, this would have vents. So when the air is being pushed through, the middle of the rice pile, the center would be dried, because this would have air vents. I don't know, by trial and error, I'll start with the vents here first, and then experiment by trial error. Basically, that's how it's gonna be, because for anything like this, there's going to be an experiment or a test of how this thing would perform. My thought too is to stack these one more. So this is about what is this? How high? Yeah, it's the height is 43 inches tall. So 43 inches tall, 53 inches diameter. You could calculate the volume. I plan to have the pedestal here. It's about 8 inches high. So basically, the effective volume would be 32 the height and 53 diameter, 1/2 h, 1/2 pi h by diameter. So that's your volume. Oh no, that's the area. Let's see. 1/2 pi h d squared, or d over 2 squared times height times pi. So that's the volume. Someday I'll find out how much sack that is. But if I add, for example, if I add this, then that would be even more volume being dried. But that's later on. First thing first is to mock this up. The heater would be here. It would be I have to do some power, the watts. I don't want to draw too much power. I've read that you don't want to go over 43 degrees to dry the rice. It would actually disintegrate. Do something silly to the rice if you go over 43 degrees. And then the humidity. I gotta figure that out. What's the optimum? So this whole thing would have multiple sensors, temperature and humidity sensor. I've seen the temperature and humidity sensors from Lazada, so I'll be buying those and testing them out. So I'm gonna make slats, not that girl, into this kind of size, and then put them all together. It would be going around this tube. I want it to be 4-inch. It's 3 inches, but it'll be 4-inch. I suppose 3 could work, but I wanted the air mass to be there. We'll see. I mean, this is just a prototype. It'll change over time as I understand the requirement. So I cut up some bamboo, creating this analog for the flat bar. Now, of course, when this is all put together, it would be sitting edgewise. Right now, it's a lot easier to work with flat. So, look like it'll be okay. I think that the segment from here to there, I think it's about 8 inches. So I might want to add in, for support, another piece here, but we'll see. I really don't want to increase the amount of materials needed. But then it all depends on the mass of the rice. If I need to add another piece, then add another piece. So I'm going to cut up the bamboo. I'm just gonna use the 3-inch. I don't have 4-inch, so I'll change my drawing to 3-inch, and then fit it all together and mark it up from there. Okay, I cut up some bamboo for the spokes, and then look at the concept. These thing, there would be a support here. There would be a support here. I don't think it needs any support, but there'll be a support here. Of course, there'll be a support here, ring support, because there would be load here and there would be load here. I think this is strong enough to carry maybe 1 ton, 1 metric ton. I don't know. I mean, will it carry 1 metric ton? I don't know. So that's 1,000 kilos. And this, depending on how it is, it might be I suppose I would have to use multiple layers of this, or add spokes to support the spacing here. And the air ingress, there would be a tube here, and to force the air in. So the idea of the mock-up is, for example, the mock-up, a hose with the appropriate pressure. That is to say that it needs to withstand a certain pressure. I don't know how many psi, 5 psi maybe, with the appropriate industrial fan. This is not an industrial fan, but it would be forcing air into this. There would be multiple sensors, incoming air temperature, in humidity, and I would be detecting pressure within the containment system. Then there'll be a temperature, a heater there. Again, it all depends. So this thing would have multiple temperature humidity probe, so that I just shove it in, and so I can check the dryer. This thing will be computer controlled. It would have to be that because my intention is to have this running 24/7, and for that to happen, it has to be a machine controlling the whole drying cycle or drying system, drying procedure. So this is the proof of concept. That's the idea. Now the reason why I'm sharing this, I want to have people looking at this and say, this guy has some ideas. Maybe we can do something with it. I really don't care if they build upon this idea. It's all for the good. The Philippine farming community needs to industrialize themselves. The industry is really suck. The farmers don't help each other for some reason, and so thinking about rice dryer, there's a need for it, especially in second cycle. And I hope to have this completed before the second cycle. I really don't need it for first cycle, but for second cycle, that's when I I would have it completed. I would be using some of the rice in the first cycle to do some trial and see what happens and tweak it. So the idea at the moment is to use the generator to electrify the heater. It's all heating element. You could buy that from Lazada. It's called nichrome wire. So you make your own heater. There's a lot of industrial fan. Like this is for kiddie. You know, those bouncy things. They use this kind of fan. But if you industrial, so if you use an industry type pump, air pump, then I would do the job. Maybe 1.5 HP fan. This is 110 kiddie, bouncy kiddie fan. So for the trial run, this is that. We're gonna use it. I might end up using the dryer, the clothes dryer for the initial prototype. I mean, why not? It's there. So yeah, hopefully you get some ideas and say, yeah, I could do this. You could. It's no big deal.